We're at the headquarters of MARC Radio in Gainesville, Florida. From this facility, they send the programming to the station's transmitters in 4 different locales. That is both AM and FM.
When storm season comes here in Florida, it can get very bad. Lightning hits would take out equipment on a regular basis. We'd have outages almost every other week. We would have listeners turning the radio station, working hard to get them back. It was a nightmare.
When we got here, the grounding was well in excess of 200 ohms. That's not acceptable. That's almost 10 times the NEC maximum recommendation. We found that the tower needed to be regrounded as well. So we grounded the tower, and we also regrounded the electrical system by putting a ground field actually in a retention pond. Normally we try to use a triangular or a round shaped layout. But because we wanted to get to that retention pond, we ran almost 200 feet of cable going out into that retention pond. Rods in the retention pond are about 50 feet apart, and they're about 50 feet down. The rods at the tower are 70 feet, and they're almost 70 feet, about 60 feet apart. This 4-aught was run as an insulated 4-aught because we have to go through building steel and penetrations where there's steel involved. We did not want to pick up anything other than what we were doing in the outside. We didn't want to cause a problem. One of the biggest mistakes that people make in circuiting a facility is they put loads that are inappropriate and mix them with other loads. In this case, this panel has parking lot lights that will bring lightning back into the panel. The 2 main fire alarms are on the same panel as the parking lot lights. An air conditioning compressor's on here. The elevators are on here. They're very inductive loads. They have no business being on the same panel as those fire alarms. It's improper. The way this is fixed is you take the critical circuits like the fire alarm, those are isolated on their own panel. They don't have parking lot lights, they don't have elevator motors, they don't have anything that is inappropriate. Only sensitive loads on that panel. The parking lot lights should be isolated on their own panel, period. And it would be surge protected, as well as this panel being surge protected. But surge protection alone does not resolve the issue of mixed loads. Surge protection is just what it is. It's surge protection. It's not an all-encompassing power quality device. It only takes an overvoltage and shunts it to either neutral or ground or between lines. That's all it does. Here we have 2 different services coming in. One of them is a coaxial service, and one of them is regular telecommunication lines. The telecommunication lines are protected with gas tube arresters. That's code required. FCC requires this. They're life safety. Unfortunately, they have bonded both of the grounds off of the cable and of the gas tube arresters to the same ground bar. They should be home run directly to the ground source. They should not be bonded together. That is improper because cross-contamination occurs. If there's a surge that comes in from lightning on this phone line, it's transferred to the shield of the coax because they're both bonded together here. It should be further downstream. We're in the heart of the operation. It's a combination of IT, it's a combination of control room, everything comes here. This is what makes the place happen. This is where all the signals come before they go to the respective transmitters. If this room doesn't work, they're out of business. They are down totally. The problem here is to maintain power quality, power consistency, and to not have any outside wires bringing problems back into this room that will cause equipment downtime and damage. Let's just say we've got a coax cable coming in, which we do, several of them here. They all have to have a ground to the shield. If that shield will have lightning on it, it doesn't want to go towards the equipment. It wants to go to a lower potential and easily. When you combine a phone board and coax and all the other modem things with sensitive equipment, and you hook them all to one ground bar and only have one wire going back, that creates a high impedance situation. That energy is going to be transmitted back to all those other connections. So you've just contaminated everything hooked to that ground bar and take a good chance on blowing it up. That's wrong. That is improper. That does not work. You've got to segregate this stuff and you have to isolate it In order to do that, you home run them to a low impedance ground. This facility has two sources of power in effect. The power that goes through this transformer that goes to this UPS system that feeds all of the sensitive equipment. Right now, we have loads that are on the UPS and also on regular street utility power that share different ground references. They're communicating between them, and they must be on the same ground reference. They can't have two different ground references. That's not allowed. That will destroy this equipment and knock these people off the air. All of this is going to be referenced to the ground of this transformer, which is the power source for that UPS. The UPS drives all the equipment. Everything else in here that is not powered by the UPS has a regular utility ground path. That's it.
The grounding and bonding has been a very good investment. It's in the radio station business, being on the air and retaining customers, keeping them from changing the channel is how we make money. So the investment in the grounding and bonding more than paid for itself.